Alrighty, let's try this again. I just recorded one of these and found out that the sound wasn't on the entire time. So, here we go. Round 2. The coordinates of point A are 3, -5. Let me move this down. Okay, the coordinates of point A are 3 and -5. So I'm going to go 3 to the right, 5 down. Alrighty, and that is A. If A prime is the image of A after rotation of 270 degrees about the origin, what are the coordinates of A prime? Well, first thing to know is that if it doesn't state which direction, positive is assumed to be counterclockwise. So, what I would recommend is doing a rough estimate of where you think it'll land based on just drawing a circle and going around roughly 3/4 of the way around a circle. Okay? That way, we're able to eliminate some of the choices that we have. So, looking through our choices right now, just based on this, 270 degrees counterclockwise, somewhere in there. 1 is in the second quadrant. -3, 5 is up here. So that doesn't work. Number 2 is 5, 3. That's in the first quadrant. That doesn't work. Now we have this one and this one. So I'm going to take a look at number 4 first, just for pedagogical purposes. And I'm going to plot a point at -3, -5. So -3, -5. If I draw a line from my preimage, which is A, up to my center of rotation, and then from my center of rotation down to here, I can see that that's not really 90 degrees. And I know that a full circle minus 90 degrees would be 270 degrees. So I'm not completely sure, but I'm pretty sure that that's not the correct answer. Now, let's try the other one. -5, -3 would be right there. Okay, let me put that in green. Alrighty, now if I draw this line, so if I connect these lines, okay, so we go from A up to our center, and then from our center over to here. That looks more like 90 degrees. So just based on that, I'm going to go with 3. But here is the actual reasoning. We know that this should be 90 degrees, and therefore these line segments are perpendicular. As we'll learn later in the year more in depth, the slopes of perpendicular lines are negative reciprocals of each other. So the slope of this line is down 5 over 3, -5 over 3. The slope of this line, this one right here, is up 3 over 5. Not equals. Up 3 over 5. I can see that these numbers have flipped and the sign has changed. It went from being negative to being positive. That tells me for sure that these lines are in fact perpendicular. But if we're just doing the eye test, we can definitely tell that that one's 90 and that one's not. Okay? So, yeah, there's that. Okay, so 3 would be our correct answer there. Number 2, what property is or properties are preserved under a rotation? Rotations are rigid motions that maintain size and shape, or distance and angle measure. And I'm going to keep a note here of what time that was, 4:35 about. Okay. Rotations are rigid motions. Rigid motions maintain size and shape, or otherwise known as distance and angle measure. So we know it's B. And just to go a little bit more into depth about that, if we have a shape and we rotate it, it doesn't change how big it is. So it maintains distance. And what we mean by distance is, if I have this triangle and I rotate it, the distance between these points is going to be the same. The triangle isn't going to be bigger. This distance isn't going to change from being that distance. That's what we mean by maintaining distance. For maintaining angle measure, or shape rather, if we rotate this triangle, it isn't going to automatically look like this. This angle isn't going to change and become bigger. It's going to maintain the same size. The angle measure is going to be the same. So it's going to maintain the same shape. So that means that we are maintaining distance and angle measure for a rotation, aka size and shape. Number 3, if we reflect it over the line, we are going to reflect it. We're not even going to say if. So to do a reflection, you see how far away a point is from the line of reflection, and then go that same distance on the other side. So I can see here it's about that far, so I'm going to go about that far on the other side here, which puts my point E prime roughly right here. If I draw a segment between E and E prime, I will see that it is in fact being bisected by that line of reflection, and it's perpendicular. And I can do that for all of my points. I have to go roughly this far for B, so I have to go roughly this far for B prime. I have to go this far for C, roughly this far for C prime. And then for D, that'd be roughly right here. So that's D prime, that's C prime, E prime is up here, and then B prime. And I can connect all of these. So we can see here that we truly do have a reflection, to the best of my ability. All right, now to get on to our question. It's asking which of the following is not. You do have to read, guys. You do have to read. So CC prime is perpendicular to X. Well, let's draw CC prime and see what happens. I'm going to connect C and C prime. I do see, no pun intended, that is perpendicular to our line X. It makes sense. The line of reflection is the perpendicular bisector of that segment. So that is correct, but it's not our answer. CD is equal to C prime D prime. That also makes sense, that this segment would be just as long as this segment, because as we just got done saying, rigid motions maintain size and shape. So that is correct, but it is not our answer. The measure of angle B. So B is right here. It is congruent to B prime. Well, rigid motions maintain size and angle measure. So angle measure is maintained. So that is correct. Now, BE is parallel to B prime E prime. If I draw BE and B prime E prime, I can see that they are not parallel. So this would be our answer. Alrighty, and that is, what time is that? 9:25 about. All right. Okay, on to number 4. Graph and label. MNO. It's the image of QRS. So we're giving QRS, they're asking us to find MNO, which is the image after a reflection. So I'm going to start by drawing my line of reflection. the line of reflection is y equals 3. Pause the video and see if you can think of where the line y equals 3 would be. Well, it would intersect the y-axis at 3, which is right there. Yay! So if you drew that, good. If not, you need to practice that. It is important, and you need to stop getting it wrong. Please! Okay, now, to do a reflection, we do the same thing as we did before. So we see how high above the point is, and if it's above, we go below. If it's below, we go above. So R, or let's start with Q, because Q is the first letter. So Q is one below, so we have to go one above. Directly above, not to like the side. Directly above. That becomes point M. R is 2 above, so now we have to go 2 below. 2N. S is 7 below, so we have to go 7 above. And we're going above this pink line, not the x-axis. We're going 7 below the pink line, so it has to be 7 above the pink line. Therefore, we get our triangle MNO. Very cool. Very symmetrical. Very nice. Alrighty, let me see why that isn't showing. Alrighty, number 5. Describe a sequence of rigid motions that will map quad ABCD onto quad EFGH. Quad means quadrilateral. So, this is our pre-image, and this is our image. First step is to do a translation and map a pre-image point onto its image. Well, thinking about this, let's see our first pair, A and E. If I take A and I take this whole shape and drag it up here on top of that, let's take a look and see what that would look like. I want to pause the video. So, if I want to put A on top of E, it would look like this. That's pretty messy. The thing is on top of each other, that would be pretty bad. Okay, let's try the next one. B. B matches onto F. If I do that, then I'll have some points off the grid. That doesn't really work. Okay, now C. If C matches onto G, we still have some overlap. Still pretty messy. Okay, so that doesn't really work either. Now, D. If I map D onto H, because they're both the third letter or last letter, that's pretty nice. Our picture's still on the grid. There's not any overlap. It's nice and neat. So I'm going to go with that. So, now it's time to name it. A becomes A prime. B becomes B prime. C becomes C prime. And D becomes H. I could call it D prime if I wanted to, but it's already got a name, H. So that was a translation, 5 to the right, 2 up. And it took A, B, C, D and made it A prime, B prime, C prime, H. Now I need to reflect it over this line because my orientation changed. I should have done that before, but I didn't. This one was counterclockwise. This one was clockwise. So I know a reflection occurred. So it's a reflection across the x-axis, which is otherwise known as y equals 0, or the x-axis. I'm going to call it the x-axis. And I'm taking A, B prime, C prime, H, and making it E, F, G, H. There you go. Alrighty. Next one, number 6. Construct a line of reflection. All right, this one will be a little bit different than what you would do because I'm working on a computer. So I'm going to create a line between a pre-image point and its image. I'm going to choose A and E because they're right next to each other, and they're both the first letter, so I know that they match up. So A goes to E. I then am going to use my compass, which in my case is a circle, and I'm going to open up my compass more than halfway. So I'm going to draw a circle that is more than halfway of that segment. Okay, somewhere right there, and I'm going to center it on that point. Now, I'm going to copy and paste my segment, aka for you all, I'm going to create a segment that is the same size as the first, center it at the other point, and draw my arcs. Now, I connect my two with a line, and this will be a little bit messy here for the beginning, as long as I don't draw a circle. Let's see, if I do this, I can connect those two, that'll work, but I want to extend it out just a little bit further. So I want to go from here, there we go, that works a lot better than last time. There you go. That is my line of reflection. I can label it, let's call it XZ. And I have to use properties of rigid motions to explain that why they're congruent. So ABC is congruent to EFG because reflections are rigid motions which maintain or which keep size and shape, or maintain distance and angle measure, whichever you want to say. Okay, there is that one. Number 7, if BCD is reflected over the line M to map onto B prime, C prime, D prime, which of the following is not true? So C would roughly be here, or C prime rather. D prime would roughly be here, and B would roughly be here. B prime, B prime, D prime, C prime. I don't really know how people try to answer this without drawing a picture. Okay. D and D prime. Well, reflections maintain distance and angle measure. So yes, D will be congruent to D prime. So that is not an answer. Perimeter of BCD is equal to the perimeter of B prime, C prime, D prime. Well, reflections are rigid motions that maintain distance and angle measure. So the distance around this triangle will be the same as the distance around that triangle. So that is not our answer. DC is congruent to D prime, C prime. Well, if it's a reflection, reflections are rigid motions that maintain distance and angle measure. So that is not our answer. So we know that D is our answer, but let's just check. BCD and B prime, C prime, D prime have the same orientation. That can't possibly be true because a reflection occurred. That means the orientation changed. This one is counterclockwise. This one is clockwise. Okay. Next, number 8. Which of the following sequence of rigid motions happened below? Well, the primes tell us the order. So this one came first. This is our first pre-image. And this is our second image. And this is our third, or pre-image, image. We could call it the other image, however you want to say it. First, well, the orientation of this one is clockwise. The orientation of this one is counterclockwise. So we know a reflection occurred first. So A is not the answer. Now we're here, and we need to get over to here. Okay, well, this one has counterclockwise orientation as well. So we know the reflection did not occur. So that crosses B out, because they're saying a reflection and then a reflection. Now, we have to tell whether a rotation of 90 or a rotation of 270 occurred. First step would be to draw a line between your pre-image and your center of rotation, and your image. We can see that it's 90 degrees, but we can't really tell if it's 90 or 270. Remember, positive is considered counterclockwise. So if I start at my pre-image and I rotate around to my image, that counterclockwise is 90 degrees. So this would be my correct answer. It would, however, be negative 270 degrees. So this one would be correct if there was a negative, but there isn't, so it's wrong. Okay. Next one, number 9. If you can map one triangle onto another using rigid motions, then the triangles are congruent. Maintains distance and angle measure. Cool face. Number 10. Describe a sequence of rigid motions that maps quad WXYZ onto ABCD. Pre-image, image. First thing is a translation. So I'm going to map W onto A because they're both the first letter. To tell what kind of transformation comes afterwards, WXYZ, that's counterclockwise. ABCD is clockwise. So I know that a reflection will occur. So I'm going to translate to the right 3 and down 8. Translate to the right 3, down 8. If I do that, my picture, if I do this one, right 3, down 8, that puts me right here. And then right 3, down 8, that's right here. That becomes Z prime, that becomes Y prime. Connect my points. Alrighty. So this was triangle W, or not triangle, quadrilateral WXYZ, and it's becoming, well, W becomes A, X becomes B, Y becomes Y prime, and Z becomes Z prime. AB, YZ. Prime, prime. Next, is there a reflection? If you didn't get the last one right, here's your time for redemption. What is the equation of that line? It is a reflection over the line. Y equals -5. It intersects the y-axis at -5. Therefore, it is a reflection over y equals -5. So a, b, y prime, z prime becomes a, b, c, d. Sorry if I called that a triangle again. Number 11, the last one. Use properties of rigid motion to explain why. Well, first we need to figure out which rigid motion occurred. Doesn't matter which one's your image and pre-image. I like going the order that they're written. So this is pre-image. This is the image. QPO. That's counterclockwise. NPK. That's also counterclockwise. So we know that a rotation occurred. It is rotating around point P. So if you wanted to write this out, you could say a rotation about P until, pick a pre-image point. That could be point Q or point O, or a segment like QP, QO, or OP. I'm going to go with point Q until Q maps onto, well, Q has to map onto N. So until Q maps onto N. I can see here, Q would map onto N. It would probably be 180 degrees, but we can't quite tell. So just going to leave it like that. So use properties of rigid motions. That would be triangle QPO is congruent to triangle NPK because rotations are rigid motions that keep size and shape, or maintain distance and angle measure, either way you want to say it. Alrighty, that's the video, that's the key. Would wish you luck on the test, but doing the work and seeing your teacher for help be much more beneficial. Mr. Briggs, out.